Welcome to this new chapter of Element X tutorial videos. In this chapter, we'll dive into an exciting feature of Element X, the surfacing tools. Using these tools, we'll demonstrate how to repair planar surfaces based on 3D scanned data. Here's the journey we'll take together. First, we'll analyze the deviations to pinpoint where repairs are needed. Next, we'll extract and isolate the damaged areas, focusing only on the critical zones. Finally, we'll generate a precise path for refurbishing, tailored for CNC machines. Whether you're using laser DED, PTA, or MIG welding, Element X equips you with everything needed to restore and refine your parts with precision. Now, let's begin this transformative process and unlock the full potential of your scanned data with Element X. First, let's look at the point cloud we are working with. We'll start by examining the relative depth of the scan. This gives us a valuable overview of where the damaged volumes are likely to be. Next, we'll quantify those deviations by computing a deviation map from the point cloud to a nominal planar surface. With the color map, you can actually quantify the deviations by examining the two-dimensional graphs displayed at the bottom and right corners of the visualization window. These graphs highlight the deviation to the nominal plane along the two straight red and blue lines, and you can interactively analyze this by moving the pointer across the map. Now that we've accurately quantified the deviations, we can move on to extracting the damaged areas. To do this, select the Identify Damaged Areas button. Use the drop-down input to choose the point cloud you want to work with. Select the surface geometry type, in this case, planar. Set the accuracy level for damaged area identification. For example, a value of 0.5 means all points that deviate from the nominal plane by at least 0.5 units will be extracted. Finally, press Run to extract the damaged areas. This function returns the point clouds corresponding to the damaged areas, the reference plane that was used to extract these volumes. The damaged volumes are output as point clouds. To generate a path for refurbishment, these point clouds need to be converted into surfaces. Here's how to do that. Click on Compute Damaged Volume. Select the initial scan as the damaged surface. Choose the damaged cluster you'd like to work with from the volumes identified earlier. Use the nominal plane as the reference geometry and select planar as the surface type. You also have the option to generate watertight meshes to create solid meshes from the damaged cluster. These solid meshes can then be exported into a CAM software for toolpath generation. Element X is capable of generating paths for both solid and hollow meshes. However, note that using watertight meshes will require more computational resources, making the process more intensive. Now that we have a mesh, we can work on generating a path. To do so, click on Generate Additive Toolpath. In the corresponding window, you will see 5 sub-windows. Please refer to the tutorial on additive manufacturing path planning for more details. Select the geometrical and process parameters corresponding to your machine and material. Finally, press Run. This will generate a G-code that can be loaded onto your machine via USB or ETHERNET for execution.